All right, so now what we're going to do is we are going to take graphs of functions and create composition functions out of them, okay? So here's what we have. We have this function right here, this curve, this purple one, that's f of x. And this linear function right here, that's g of x. And what we're told is that a third function, h of x, is the sum of these two functions, f of x plus g of x. And what we're being told to do is to graph h of x, okay? Now, we're going to be very limited here because some of these values might wind up going too high or too low, so we're only going to graph what we are capable of graphing, okay? All right, so what I would do here if I were you is basically what we're going to do is we're going to go vertically along these vertical lines at 1, 2, 3, 4, 0, negative 1, negative 2, negative 3, negative 4, and we are going to do whatever the function tells us to do, okay? It's telling us to add the value of f of x to the value of g of x. Now, there are a few ways you can do this, but I'm going to show you, one way to do it without making a table, but if you want to create a table, you can, okay? I'm going to start at 0, and here's what I know is you can see that at 0, the function f of x is going through the point 0, right? So at 0, well, let's go ahead and write it here. F of 0 is equal to 0. And g of 0, well, let's find out what g of 0 equals. Negative 1, negative 2, negative 3. See, it's crossing over here at negative 3. So f of 0 is 0 and g of 0 is negative 3. And what that means is that if we were to add these two together, we'd get 0 plus negative 3. So h of 0 is equal to negative 3. And that means that when x is 0, y, or h of x, is equal to negative 3. So we can plot the point 0, negative 3. So from here, 0, and then negative 1, negative 2, negative 3. The graph of this function is going to go through that point right there. Okay? All right? Now, let's pick another x value. Basically, what you're doing is you're just picking x values. Okay? Let's go to negative 1. Okay? At negative 1, we can see that f of x is positive 1. So f of negative 1 is equal to positive 1. And then g at negative 1 goes through negative 1. And so g of negative 1 is negative 1. And so now h of negative 1 is equal to f of negative 1 plus g of negative 1, right? Well, that's 1 plus negative 1. Well, that's 0, right? So 1 plus negative 1 is equal to 0, and therefore h of x passes through the point negative 1 and 0. So at negative 1, we're going to put a 0 right there, okay? All right, now let's move on to, let's try negative 2. Let's go backwards a little bit. Let's try negative 2. Here's another way you can do it. You can go to negative 2, and you can just go up, and you can see that f of x goes through 4, right? And that g of x goes through 1. And you can just add them together. 4 plus 1 is 5. So we know that h of x is going to go through negative 2 and 5. 1, 2, 3, 4, 5. So we're going to put a dot right there. All we're doing is adding together the heights of both functions. The height of this function is 1. The height of this function is 4. 1 plus 4 is 5. So we know that h of x is going to pass through negative 2 and 5. How about at 1? Let's go in the positive direction because that looks like it's going a little high. In fact, let's see here. If we were to go to negative 3, we'd have a height of 3. G of x has a height of 3, okay, 3. And f of x has a height of 3, 4, 5, 6, 7, 8, 9. So we'd have to do 9 plus 3. That's 12. Well, our graph doesn't go up to, well, it does way up there, but I'm not going to put a dot on the wall. Just understand that this goes much higher right there. All right, so let's try positive 1. Let's go this direction. Positive 1. At positive 1, f of x is equal to 1. And g of x is negative 1, negative 2, negative 3, negative 4, negative 5. And so we just have to add negative 5 and positive 1. That makes negative 4. And therefore, h of x is going to go through 1 and negative 4. 1, 2, 3, 4, which is right here. Okay? Okay, so we can kind of see the shape here. H of x is going through here, 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 and here. All right, let's do a few more. If we were to plug a 2 in, or if we were to go to 2, f of x is 1, 2, 3, 4. Okay, 4. And g of x is -1, -2, -3, -4, -5, -6, -7. So we just have to add -7 and 4. Well, -7 plus 4 is -3. So at 2, we're going to go down to -1, -2, -3, put a dot right there. Okay? All right. Moving on to 3, we can see that the height here is, wow, that's really high. F of x is 9. Okay? So this is 9. And g of x is 1, 2, 3, 4, 5, 6, 7, 8, 9 down. That's -9. And we know that -9 plus 9 is 0. Therefore, at 3, it's going to be 3 and 0. Okay? I don't think we're going to be able to do 4 because we can't see how high the graph is at 4. And we can't f of x, and we can't see how low g of x is at 4. So we're done. This is it. So we know that h of x passes through here, 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 and here. And we can actually sketch the curve. We just got to go through all of the points. It's going to flatten out right here. And we can see that that is probably the shape of h of x. Okay? So this is, and it probably goes up this way. This is the graph of h of x. And that is doing composition functions, combining them together using graphs. Okay, I want to do one more example of this, and I think that you're gonna understand this pretty well. All right, so here's another graphical example. What we have here is we have two intersecting curves, and that's one of the reasons why I'm doing this particular example, so that you can understand what happens when the result of two intersecting curves. This one right here, this one that's sort of a parabola turned downwards, that's g of x. This one that's a parabola turned upwards, that's f of x. And h of x, our third function, is equal to g of x minus f of x. Okay? So what we're going to do is we're going to basically do, let's say from 0. Looks like we're only going to pull off maybe 0 up to 6. Okay? So we'll start at 0 and we'll plot points for h of x all the way up to 6. So we're going to do g of x. So starting off with g of x at 0 is -3, okay? And f of x at 0 is 7. So we're doing -3 minus 7, right? So -3 minus 7 is going to be -10. Yeah, we're not even going to be able to plot. Oh, yeah, we can. Here it is, -10 is right down here. Okay, so we can go from 0, we can go down to -10 and plot a point right there. Okay, 0 and -10. All right. Now let's move on to +1. We're going to do g of x first. We have to go up to g of x. Oh, they're both right there. They're both at 2. G of x is 2, g of 1 is 2, and f of 1 is also 2. And 2 minus 2 is 0. Therefore, h of 1 is going to be 0. So when it equals 0, it's on the x-axis, right? So we're going to plot that point right there. All right, so at x equals 2, g of x is up here. That's 5, okay, 5. And f of x is -1, and so 5 minus -1, that's +6, right? Okay, so we're going to plot 2 and 6. 1, 2, 3, 4, 5, 6. That's way up here. I'm going to plot that point right there. Okay. Then we're going to go to 3. G of x is 6, and f of x is -2. So we've got a -2 here and a 6 up here. 6 minus -2, that's 8. So we're going to plot the point 3 and 8. 1, 2, 3, 4, 5, 6, 7, 8. This point right here. There we go. Now we're going to move over to 4. And 4, at x equals 4. So g of x is going to be equal to 5. And f of x is equal to -1. So 5 minus -1, because it's g of x minus f of x. 5 minus -1, that's a +6. Well, that's 5. Here's 6 right here. So 4 and 1, 2, 3, 4, 5, 6. All right. All right. And then a couple more here. At 5, g of x is equal to 2, and f of x is also equal to 2. So 2 minus 2 is 0. So we're going to plot 5 and 0. And you can see the shape of h of x. It's starting here. It's going to go up through here, then through here. Then it's going to turn around there and come back down through here, go through here, and then let's just go to 6. At 6, g of x is negative 3, and f of x is 7. And so, negative 3 minus 7, that's negative 10 again. And negative 10 is all the way down here. So now, here's what I'm saying, is that the equation of this function, of this particular graph, is going to look like this. It's going to pass through there. There's a turnaround. It's a parabola. It's going to pass through here and here. And it's going to go through this point, and it's going to come all the way down here to negative 10. It's going to be the exact same thing on this side. It's going to go through this point, come all the way down here through negative 10. Now here's something interesting I want to show you. I'm going to go ahead and remove these other two graphs temporarily and show you something interesting. What this graph now is showing you, it's showing you the distance with g of x on top and f of x on the bottom. And whenever g of x is above f of x, we have a positive difference. And that's represented by this region of h of x, which is above the x-axis. But in this region right here, where h of x goes negative and h of x goes negative over here, that's indicating that those are places where f of x is actually above g of x. This positive region here is very meaningful in calculus. I'm not going to explain how because this is a pre-calculus class, but I'm just getting your brains ready for you to see situations where you have intersecting curves and you make a new function that is based on one of the functions minus the other function. Okay? All right, that's it. That's the basics of composition functions. I hope this helps you out a bit. I understand that it's a little frustrating, a little confusing, but just do your best with this. The more that you're able to do this, the more that you practice with this, the better you will be ready for higher levels of math in your education.